Okay, thank you. Hi everyone, my name is Minseong Kim from Linaro Mobile Group, of course, and this session is with two speakers. So I will go first, explaining about our continuous efforts on building AOSP master with Clang master, and then the next and main presenter, Bero, will explain about his efforts on building kernels, bootloaders, and teas with Clang. So in the middle of speaking, so if you have any questions, just raise your hands and ask. So building AOSP master with Clang master. The primary reason behind of this work is that the pre-built Clang in the AOSP that is shipped with AOSP as a default toolchain is normally lag behind in time 3 to 6 months compared to the Clang master. So to bridge this time gap, we have been using Clang master for building AOSP master. By doing it, this work effectively enables us to check Clang master's performance and size impact on AOSP in terms of ARM's perspective, and it also allows us to help Clang master to soft land on the AOSP when the time comes. So for this work, we created two CI jobs. The first CI builds Clang master using the similar commands build.py script, which is used to build the pre-built Clang in the AOSP. And the second CI builds AOSP master using the Clang built from the first CI job. Of course, there are some minor patches to apply to AOSP. The patches are mainly about tuning compiler flags to bypass newly added errors and warnings, which are more strict in the Clang master. We also find bugs early. In such cases, we fix upstream directly or report the bugs to the relevant bugzilla as well. And if you want to check history and the status of the CI jobs, you can visit the links on the screen. And also, the two CI jobs frequently fail as they are two moving targets. So this work requires constant maintenance, such as debugging and making patches and etc. So upon success of the two CI jobs, the resulting binary images are sent to a boot up test on HKG using Lava, so that we could make sure the resulting images are working okay. So we also crunch numbers too. So this slide shows performance and size comparisons between Clang master and the pre-built Clang. The size difference is not much, roughly 0.1% difference in size. However, performance improvements are quite significant sometimes. As you can see on the screen, it is a couple of percent better with the Clang master. But some other times, there are no visible performance increases compared to the pre-built Clang. Fortunately, we haven't seen cases with performance and size regression so far. So based on these results, the Clang master is going in the right direction in terms of performance and size in ARM's perspective.
Is this AR32 or AR64?
It's mainly AR64.
And the performance test, is it like more than one iteration you ran to?
Yes, of course. Normally, yes, 3 times, and this is average. And to make things a little bit more interesting, we also apply some new compiler techniques to the Clang, which is in turn used to build AOSP. Firstly, LLD. LLD is a LLVM linker, which is designed to be a drop-in replacement for GNU linkers such as LD, BFD, and Gold. The current default linker for ARC64 AOSP is Gold. So we tried to replace Gold with LLD for linking entire AOSP. But in doing so, we found a few issues, such as 3 missing options in LLD, which are supported by other linkers, and some other compatibility issues between LLD and AOSP modules. So with some workarounds to mitigate these issues, the resulting binary size increases by roughly 7 or 8%, which isn't really good. So we reported these results and issues to the relevant parties of the ecosystem, and I believe they are actively working on these issues to make LLD to be more compatible with AOSP. And Super and Poly, they are more aggressive optimization technique for Clang. So we apply them to the Clang, which in turn used to build AOSP master. Unfortunately, we haven't seen any performance increases. However, we could use our Clang build framework used in this work to apply new compiler techniques to the Clang pre-build, which can be used to build AOSP master. This is because normally new compiler techniques are developed against master branches, so it would have been very difficult to apply new techniques to the Clang pre-build. So we now know how to check these new compiler techniques effect on AOSP to see what their behavior is on the AOSP in advance. So okay, that's all from me. If there is any questions. Okay, so my assigned contract with Linaro finishes soon, so someone else from Linaro, I hope, steps in to continue my work. Okay, yeah, I will pass the mic to Bero.
Yeah, and we will definitely try to continue your work, but it won't be the same without you. But yeah, I will definitely look after those builds for a while until maybe a new assignee comes in.
Okay, cool. I guess you can take the question now, or do you want to wait to the end where you've got microphones?
We can take questions right now.
No, just how closely do you work with the Google upstream team? Is it sort of just do you communicate by PRs and or bugs type of thing, or are you sort of can they see the results of these sort of continuous integrations?
We've been talking, sending bug reports, sending patches in Garrett.
Right. Okay.
But I don't think
yeah, I think they are working to get closer to the tip of the trunk all the time.
Yes, true.
Yes.
We talk to them directly. So.
Yeah. Yeah, I started doing some work on improving LLD. I don't know. I guess you run that once, and you're not running that continuously.
No.
That's okay. Yeah, if you ever do start running that continuously, do let me know, and I'll see what I can do to help get those things pushed in. Because I've managed to fix a few of those.
Right.
But so I think LLD and Android may come along in the future. If we can get to the point where it's at least as good as Gold.
yes, and actually LLD on Android as well as Poly and other things that are still maintained upstream are not things that we only tried once and will never try again. So essentially we did a couple of runs to see what they can do right now and decided they're not ready yet, and we don't really have the resources to put into fixing them. So when the next major release comes out, so probably with the release of Clang 7 or so, we're going to check again.
One final question is, when you say the test that you perform, is that, I guess there's a boot up, and is there a sort of system self-test that you run of sort of integrity, or is it just, oh, it boots up, that's all we can really do at the moment.
Yeah. Essentially, we have one test that boots up and then runs a couple of benchmarks, which is what we've used there. And we could run all of CTS and VTS if we had a really interesting build.
Right, okay.
But of course, those things take time to run, and therefore we don't do that on just simple test builds.
Okay.
Okay, anything else on this? No, I don't think so. So, next topics are building kernels and bootloaders and TEs with Clang. So, in terms of mainline kernels, we are looking good, except for some rarely used modules like XOFS and of course GCC code analysis plugins that will never work with Clang. The kernels can build with Clang 6.0 and related snapshots on ARC64 and x86-64. And v7 is a little bit behind because there's some more inline assembly that the internal assembler doesn't like. Mostly a matter of getting rid of some old style assembly constructs. But it isn't very far from working, so probably until next Connect we'll also have 32-bit kernels working well when built with Clang. Relevant patches related to this have been backported to Android commentaries that are still relevant, so most kernels should be buildable with Clang these days in the Android world. The situation, however, is that building the kernel with GCC is getting a lot more testing, and for production builds we'd still recommend using GCC most of the time. And we prefer using the latest version of GCC coming out of the toolchain working group over the outdated 4.x based AOSPs that are in AOSP pre-builds, because those things are really far behind and essentially abandoned. We have already run a couple of tests with GCC 8 previews as well, and that is also looking good.
Do you know which toolchains Google is using for building kernels internally?
We're using Clang.
Yeah.
Yeah. We don't use GCC for anything.
Kernels with Clang?
Yeah.
Modified kernels or still?
Well,
if ARMv7 doesn't build with Clang?
Yeah, but we don't have any products based on ARMv7, so we don't build those.
Yeah, the next complicated topic is actually building bootloaders with Clang. The one we've looked at initially is U-boot, and there's still a lot of GCC hardcodes from compiler naming conventions in makefiles to compiler flags that are being forced to inline assembly that is not compatible with what Clang expects, which can be worked around by using the -fno integrated AS, but you still won't get to a working U-boot yet. It looks like it is clearly possible to fix this, but it will take some more time, and we don't have a lot of people working on this right now. So unless we get more assignees or member engineers involved in it, there's no promises that we can have this working by next Connect, but of course would be nice, and we'll see if we get around to it. Then there's a question to people in the audience: are there any bootloaders other than U-boot that you're interested in that we should be looking into? Maybe Tianocore, or are there any others? Okay, doesn't look like it. Yeah, there's actually one.
I think Tianocore could be built with the Clang, but the problem is I have tried the Tianocore. Actually, it could be built by Clang. The problem is about the untrust firmware. It could be built, but it could not be linked.
Yeah, so we haven't tried doing that yet, but that is certainly one thing to look at. And that is definitely good news that it can already be compiled. Getting it to link will probably be easier. Probably just a couple of things where something is being optimized the way that shouldn't be, probably just a couple of static keywords that need to be removed or something.
Okay, I have another issue about the Clang. When I try to use, when I use the GCC, I could use the object dump, but if I migrate to Clang, this command cannot be supported.
I don't quite understand. Like object dump is just a disassembler. It's separate from.
Yeah. But for my firmware, I need to use object dump to strip something.
Right. You could use. Are you saying that LLVM object dump doesn't support the strip?
Do LLVMs has the object dump?
LLVM has an object dump.
Yeah.
But it's a developer tool type thing. I think it's generally recommends people just use GCC for that. I think LLVM has an object dump tool, but it's generally a developer tool. It doesn't tend to get in most distributions, whatever. But is there no reason you can't use the GCC object dump on a Clang built program?
But I checked the LLVM. There's no such command about the object dump. So do you have any resource on this?
But if you build LLVM from source,
Yeah.
there's an LLVM object dump program. Whether it supports strip or not, I don't know.
Yeah, there is LLVM strip as well. And there's no reason why you couldn't just use the strip and object dump utilities from binutils.
Because the firmware is running ARM, so I don't know whether another option.
Now, if you build binutils from source and specify target equals ARMv7 or ARC64, Linux GNU or GNU ABI, depending on the target, those tools will work with Clang build binaries as well. At least they work for me.
Okay.
Problem might be that you're trying to use the host tools, which would usually be built for x86 binaries instead of cross-compiler tools.
I have to use the cross-compiler tool.
Yeah. If you see any error messages or so that are caused by building something with Clang and then using the binutils tools, that's a bug, and please report it and we'll fix it.
Okay.
Same, the F layout should be same. So if he uses a GCC toolchain, I think it should be works for LLVM.
Yeah.
I think F layout is same. So if the GCC object dump works well, I think it should be okay for LLVM object dump. So I think this is a problem he encountered.
Yeah. We mix those tools all the time, so it probably is a very specific problem that we need to look at. Yeah, the next thing we've looked at is trying to get the TEs to build with Clang. Opt obviously is the first one we are interested in. The makefiles hard-code a couple of GCC-isms, and there's some older code like 412 kernel and grub that can currently be built with Clang, but a lot of other components that are part of Opti work great and can be built with Clang already. So for the moment, we still build it with GCC, but depending on the subdirectories in there, we can override it and build parts with Clang, and getting the rest to build with Clang is much like the bootloaders on our radar, but not something that has super high priority right now. So it will get better, but no guarantees that by next connectors will already be working. Another TE that's interesting is Trusty. Obviously, it also has a couple of GCC-isms hard-coded in the makefiles, and the LK kernel that's part of Trusty can't be built with Clang because there's quite a bit of code in there that's using inline assembly that Clang doesn't like. And also a couple of flag hardcodes and makefiles that should be easier to fix. But a lot of other parts of Trusty are shared with AOSP, and on the AOSP side, that code is built with Clang perfectly. So the situation there is similar to Opti. Some parts can be built with Clang already, some other parts currently need GCC. That needs to be fixed at some point. Yeah, it will be a bit of an effort, but it's certainly doable. That's pretty much all we've had prepared, so we'll take any questions.
Upstream, I saw something about ASM GoTo, the workaround that exists for old versions of GCC might be removed, and Clang doesn't yet support ASM GoTo. Is that something that you've been tracking to see what, because you might need new patches or potential lobby for support for ASM GoTo in Clang?
Now we'll see when it gets removed. It's we've heard about it, but not really spent any time on it so far. But when it happens, we'll see the breakages in our CI builds, and then that should get fixed rather quickly. Okay, anything else? I guess we are done then. So have a great lunch.